Hey there, Seahawks. It's Miss Adams, and in this video, we're going to look at finding z-scores. All right, so we use the z-score to find the probability of events occurring and to compare different distributions. To do this, we use normal probability table and the z-score formula, which is z equals x, which is your value that you're finding the z-score for, minus mu, which is your mean, divided by sigma, which is your standard deviation. All right, finding a z-score, the average speed of vehicles traveling on a stretch of highway is 67 miles per hour, with a standard deviation of 3.5 miles per hour. A vehicle is selected at random. The speed limit is 70 miles per hour. Assume the speeds are normally distributed. All right, so first, I was told this is a normal distribution with a mean of 67 and a standard deviation of 3.5. So I'm going to go ahead and label my normal curve. Right down the center, I'm going to have 67, and then I'm going to go 3 standard deviations to the right and 3 standard deviations to the left. When I add 3.5 as I move to the right, I get 70.5, 74, and 77.5. When I subtract 3.5 every time I move a standard deviation to the left, I get 63.5, 60, and 56.5. All right, find the z-score for a person driving the speed limit. Well, they told me the speed limit was 70. So I'm going to go ahead and mark where 70 would be on my normal curve. And I can see that it's just under 1 standard deviation. So if I get a value that's higher than 1, I know that I've done something wrong. All right, so z equals 70, which is my x value, minus my mean, which is 67, divided by my standard deviation, which is 3.5. 70 minus 67 divided by 3.5 gives me 0.857. So that would be my z-score. Find the z-score for a person driving 62 miles an hour. All right, well, 62 is going backwards, so it's going to be a negative z-score, and it's going to be negative 1 point something. All right, so z equals 62 is my value that I'm finding it for, minus my mean, which is 67, divided by my standard deviation, which is 3.5. That gives me negative 1.429. Find the z-score for a person driving 80 miles an hour. So same setup. This time 80, I can see that that's pretty far out. It's more than 3 standard deviations away. 80 minus 67 divided by 3.5 gives me 3.714. All right, finding an x value given the z-score. A farmer records the mean weight of pumpkins he has harvested. The weights are normally distributed with a mean of 22 pounds and a standard deviation of 3 pounds. So I have a normal distribution, mean of 22, standard deviation of 3. My curve is going to look like this. Find the weight of x corresponding to a z-score of negative 1.24. Well, if I go to negative 1.24, my z-score tells me how many standard deviations I am away from my mean. So I'm going to go back 1.24 standard deviations from my mean, and I'm going to label that as my z value. So I know I'm looking for some number between 16 and 19. So I'm going to set this up. Z equals, z is negative 1.24. My x value, that's what I'm trying to find, so I'm just going to leave it as x, minus my mean, which is 22, divided by my standard deviation of 3. Okay, so when we're working backwards, we're going to have to use some algebra to solve for x. So I'll multiply both sides by 3. That cancels on the right. 3 times negative 1.24 is negative 3.72. X minus 22, I want to get x by itself, so I'll add 22 to both sides. And I get x is 18.28. Find the weight of the course that corresponds to a z-score of 3.25. So 3.25 is more than 3 standard deviations above my mean. All right, so I'm looking for a value. I know it's going to be over 31 pounds, the pumpkin. So 3.25 equals my x value that I'm trying to solve for, minus my mean of 22 divided by my standard deviation of 3. Again, I'm going to use algebra to solve, so I multiply by 3, and then I add 22, and I get x equals 31.75. All right, go Seahawks.